Hey everyone, welcome back. We're going to do 4-4 now today, which is continuing our talk on congruent triangles. And the two conditions that we're going to look at today are angle, side, angle. So now we know two angles, right, and the side between them, and then angle, angle, side. So we're going to look at those two, and we're going to do some word problems. We're going to do some practice. It's going to be super fun. All good. So only two things that we have to go over today are the angle side angle congruence criterion and the angle angle side congruence criterion. So again, let's go to the very last page in our packet so that we can go over these quickly and come back and get started. All right, so here we are on our terms page. And let's look first at angle side angle. So obviously ASA, right? Angle, side angle. So this says if two angles and the included, this should not say angle, this should say side. And that's a typo, sorry. Okay, so if the two angles and the included side of a triangle are congruent, then the triangles are congruent. Meaning, if I have two triangles, here's one triangle, here's another triangle. And let's do something fun, like CAT for one, and DOG. Okay, so if I know two angles, so let's say I know angle A and angle O are the same. Okay, and then let's say I know that angle C and angle D are the same. So to show that they're different, I drew a tick mark through them, right? So I know that those two angles are the same. And I know the side between them. So the side between, in this case, would be CA and DO. Okay, if I know this, so two angles and the side between them, I can say that the triangles are congruent by angle, side, angle. So I can say that triangle CAT is congruent to triangle DOG by angle, side, angle congruency. Okay, so again, two angles and the side between them. So I'm literally just reading this as angle, side, angle, right? I know an angle, then a side, then an angle again. And that's it for angle, side, angle. Let's look at the next one that we're doing, which is angle, angle, side. So angle, angle, side, same idea, right? I know an angle, then another angle, then a side. So this is if I have two triangles. So again, let's get a lovely triangles drawn. That one's real bad. I can do better. Go. Let's do cat again, and then let's do pig. Okay. So now is if I know two angles, so again, let's say that I know A and I are the same. And then let's say I know that C and P are the same. Okay, so two angles. And now it's the non-included side, so a side not not between. So I can say AT. It's fine. It's congruent to IG. Okay. So do you see how this side is not between the two angles? Now we would use angle, angle, side, angle, angle, side, right? So you see one angle, then another angle, then the side. So now I can say that triangle CAT is congruent to triangle PIG by angle, angle, side congruency. Okay. So, and then the last thing I want to say is a quick reminder that ASS or SSA, same thing, does not work. So does not prove congruency. Okay, so it has to be one of these other ones that we've talked about: side, angle, side, 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 angle, side, angle, 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 side. It has to be one of those. Angle, side, side, or side, side, angle does not prove congruency. Okay, so that's it for our terms. Let's go back to 4.4 and we can go over the notes and be done. Okay, so let's look at example 1 here. Example 1 asks us, why is triangle ABC congruent to triangle DEF? Okay, well, by looking at this, I know that angle A and angle D are the same. I know that angle C and angle F are the same. And I know that AC and DF are the same length. So because of that, if I go left to right or right to left, actually it doesn't matter. I have angle, then a side, then an angle. So why are these two triangles congruent? They are congruent by angle, side, angle, congruency. Okay? We just talked about it, angle, side, angle. Also, like, we could know if I drew a line of reflection here and reflected ABC across that line, it would line up with DEF. So I can do that as well. Okay, but we're just going to look. That was example 1, super short. Let's look at example 2. So this says a technician installs cables from a cell phone tower to the ground. Right, obviously the cell phone tower needs to be able to stand upright, so we use cables to to give it leverage. I don't know. I just lost my word. It's fine, right? You install cables on the ground to make sure it doesn't fall over, whatever that's called. Oh, okay. Support, yeah, support to support the tower. Okay, great. To pass inspection, both the cables must be the same length because otherwise the tower would be leaning. Does this installation meet the cable length requirement? Explain. So the question is asking us, are these two cables the same length? So what I'm going to do is I'm going to draw these two triangles separately. And again, this is something that we did last time in the last video as well. And I apologize that my drawings are so awful, but that's okay. But kind of separating them sometimes is really helpful, okay? And then the only other thing that I see in this problem is that the tower is the same length no matter what. So that tells me that this length is the same in both triangles, okay? So by looking at this, I can now see that these two triangles are congruent by angle, side, angle. So I didn't label it, but maybe we should do that. A, call this point B, call this point C, this point D. So I can say that triangle ABD is congruent to triangle CBD by angle, side, angle. By angle, side, angle congruency, these two triangles are the same. Well, if these two triangles are the same, then I know angle A and angle C are the same. And I know that AD and CD are the same, right? So therefore, AB and CB must be the same, right? So we can say, so by CPCTC, remember, corresponding parts of congruent triangles are congruent. If these triangles are congruent, the corresponding parts are also congruent. So by CPCTC, AB is congruent to CB. And those are the lengths of the cables. So the cables are the same length. Right, so we've proved that these two triangles are equal, therefore the length of the hypotenuse or the length of the cables has to be the same. Okay, so we have a couple triads here. I want you guys to give a shot. Here's the first one. First question is asking us, are these two triangles congruent? Oh, sorry, JKL and MNO, so these first two. And then the second one's asking us, are JKL and PQR congruent? So go ahead and make sure you explain, right? So go ahead and hit pause, try these two, and then when you're ready, hit play. Okay, so let's give this a shot. If I look just at these first two, in JKL, I have angle, side, angle. And in MNO, I also have angle, side, angle. So yes, these two are the same. So yes, triangle JKL is congruent to triangle MNO by angle, side, angle. Okay. And then part B says are JKL and PQR. So again, JKL has angle, side, angle. PQR has angle, angle, side. Okay, so is that enough information? Not with what I'm given right now, right? If I was given more information or if I calculated more information or things like that, sure, maybe. But just with the information I'm given, I don't have enough information to say. Okay, so not enough information. Okay, could they be congruent still? Yeah, I just don't have that information yet. Okay, one more, try it here. So this one says find the value of x. Okay, so the first question is, are these two triangles congruent? And they are congruent here. I have 23, 62, so I know two angles. And I know a side not between the two angles, right? This is not between the two angles. So they are congruent. So we can say congruent by angle, angle, side. So since they are congruent, I know that this angle and this angle are the same. So now that I know that those angles are the same, go ahead and solve this for x, hit pause on the video, and then when you're ready to go over it, we can hit play and let's review it. All right, so let's look at this. Hopefully we started by setting these two expressions equal to each other since I know that these angles are equal. Okay, if I subtract my 2x to both sides, I'm left with 35 equals 2x minus 25. Add 25 to both sides, and I get 60 equals 2x. Divide by 2, divide by 2, 30 equals x. And that is what the problem is asking me to find. It's not asking me to plug it back in or anything. It just wants the value of x. So there we go, and I have the value of x. Hopefully we feel good on that. Okay, next example is example 3, which I actually just want you guys to try, okay? So far we have 4 congruence conditions. We have side, angle, side, 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 angle, side, angle, and angle, angle, side. So what I want you to do is I want you to go through these 4, and I want you to see if you can figure out, are these triangles congruent? If they are, by what condition? Or if they're not, you can just write neither or cannot be determined, I think is what it wants us to write. Yeah, we write cannot be determined. Okay, so again, hit pause, try it, and then when you're ready to go over it, hit play. All right, so let's look. A, I see I have an angle, then a side, then another angle, and same thing on the second triangle. So A is angle, side, angle. Okay. B, I'm looking at all three sides, right? So then this is going to be side, side, side. And that was from lesson 4.3. If you haven't watched that video, you need to go back and watch that video. For C, I have two angles and the side not between the angles, right? This is the side between the angles. Don't know that side. I know this side. So this one will be angle, angle, side. And then the last one, I know side, angle, side on this triangle. And on this triangle, I know angle, side, side. So since I don't know the same thing in both triangles, right? This one is side, angle, side. And this one is angle, side, side. And so since they're not the same, this cannot be determined. They could be congruent, I just don't have enough information to decide if they are or not. It cannot be determined. Okay, so I hope we're feeling good about being able to recognize when to use what. We just have a couple more examples here and then we're done. Make sure that you reach out and let teachers know if you're not understanding something because we just don't want you to continue to get more behind, okay? Example 4 here is a quick proof. I want to prove that FH is congruent to JL. I want to prove the base sides are the same. And I'm given that GH and KL are the same, so there's that tick mark. I'm given the angle GFH and KJL are the same, so that's the one arc measure. And then FGH and JKL are the same by the two arc measures, right? So all the information I'm given is already in the drawing. So remember that whatever's given to you goes in that first box. So I know that GH is congruent to KL, right? I know that angle, we can simplify this and say angle F is congruent to angle J, and I know that angle G is congruent to angle K. And all of those things I know because they were given. Okay. So then I guess the question is, are these triangles the same? Because if the triangles are the same, then FH and JL are the same. And so here I have angle, angle, side on this triangle and this triangle. I also have angle, angle, side. So I can say that triangle, let's do FGH is congruent to triangle JKL. And the reason that I can say that these two triangles are the same is because I can use angle, angle, side. Right, I know two angles and the side not between the two angles. Well, if these two triangles are the same, then isn't FH and JL also the same? And hopefully we say, yes, it is, right? So FH is congruent to JL. And then the reason is going to be our CPCTC, right? I've proven the triangles are equal. Therefore, every corresponding part of those triangles are also equal. So just a quick little proof right there for you. You have a try it that is similar to this, where we're looking at what additional information, okay? So here I have two triangles. What additional information would I need in order to prove that they're congruent by angle, side, angle? Or what additional information would I need to prove that they're congruent by angle, angle, side? Go ahead and hit pause, give this a quick try, And then when you're ready to go over it, hit play. Okay, so let's look here. If I want angle, side, angle, that means I need an angle, right? And then a side, and then another angle. So in this case, I need to know that angle B is going to be congruent to, and over here I have an angle and a side, and then I need another angle. So angle E. So I need to show that if I want to prove that these two triangles are congruent by angle, side, angle, I'd have to know that angle B is congruent to angle E. Okay, now for angle, angle, side, now I need to know two angles, but not the side between it. So here is going to be C, right? That gives me angle, angle, side, and F. Angle, angle, side. Wow, I totally blanked for a second, sorry. So I need to know here that C is congruent to F. So hopefully that's not too mind-blowing here, just figuring out what additional information will we need. We are on the last example where we're going to kind of take all of this stuff that we've looked at and kind of put it together into one. Example 5 says, determine congruent polygons. So it says all sides and angles of ABCD are congruent to the corresponding sides and angles of A prime, B prime, C prime, D prime. Is A prime B, or is ABC congruent to A prime, B prime, C prime, D prime? So I don't know, are they congruent? Well, hopefully just by thinking about it, if all the angles are the same and all the sides are the same, they're probably congruent, right? So like that's okay. We can just say that, right? Oops, since all angles, nope, let's change that. All corresponding angles, right? Angles that are in the same position. So all corresponding angles and sides are congruent. So since all the corresponding angles and corresponding sides are congruent, I can say that ABCD is congruent to A prime, B prime, C prime, D prime. Okay. Last one is a U try. I am given that these two shapes are the same. Okay, so I know these two shapes are the same. What is the value of X? So I need to find the side that corresponds to EH. So which side in shape ABCD corresponds to EH? And then I know that those two are equal to each other. So I want you to try this, solve for X, and then let me know, right? Or if you need help, go ahead and hit play. But I think you guys are going to do just fine on this. So go ahead and pause the video and give it a shot. All right, so hopefully we tried it, and hopefully we recognized that EH corresponds to AD, right? So EH is congruent to AD, which means those two sides are equal. So that means I can take my 2x minus 3 and set it equal to 9 and solve. So I'm going to add 3. Get 2x is equal to 12. Divide by 2, divide by 2. I get x is equal to 6. And that's what it's asking me to find. It's asking me to find x. So there it is right there. Okay, that's it for 4-4. Make sure you reach out if you have any questions or need any help. Otherwise, good luck, and you got this.